Hello everyone, I'm Harshal from team MathOratory. So today we have our rackets at Shomu sir. Hello sir.
Hi Harshal, how are you doing?
Good, I'm good. So what are we discussing today, sir?
Yeah, so we have a couple of questions, rather two questions on the same premise. So we have a single premise. This is a interesting type. I mean, you get a lot of questions built up on this type, and we'll take up two different questions on this particular type. Another time and distance problem. So let's jump into the question without wasting too much time, Harshal.
Sure, sir.
Okay. So let me just read it quickly. So we have two trains at a distance of 500 kilometers. They're running on parallel tracks towards each other. So they're moving towards each other. Speeds are given. Distance between them is given. Speeds are given. At this moment, an eagle starts from the first train and flies to the second train with a speed of this much. As soon as it reaches the second train, it immediately turns back and flies to the first train and continues to make this to and fro motion between the two trains till the two trains just meet each other. So basically what is happening is the eagle is flying from the first train to the second train and then back from the second to the first. This to and fro motion is happening, but do not forget that the trains are continuously moving towards each other, right? So when it goes for the first time, the second time, obviously it has to cover less distance and stuff. So don't overcomplicate that part, but that is pictorially, that is what is happening. Right. Okay. So continuing. So for this particular question, what are we looking for? Considering the lateral distance between the two tracks to be negligible. So basically what it's saying is because the two trains are traveling on parallel tracks, we can ignore the lateral coverage of the eagle. So we just have to consider the 500 kilometers into perspective. That is what this line is talking about. Nothing more. So considering the lateral distance, so the two tracks, lateral distance between the two tracks to be negligible. So ignore that basically. What is the total distance covered by the eagle? So in this question, we're looking for total distance covered by the eagle, which is very easy to answer. So all you have to do is understand the holistic thing that is happening. So we have an initial distance of 500 kilometers between the two trains. We know the individual speeds of the two trains. We also know that they're moving towards each other. So from these information, so basically from the first line itself, what can we figure out? Since the relative distance between the two trains is 500 kilometers, and the two trains are traveling with a speed of 120 and 150 towards each other. So that's a relative speed of 270 kilometers per hour. We know that the time that it takes for the two trains to meet should be these many hours. Yes.
Correct.
And for this entire time, so the bird starts moving at this moment, right? So at this moment, meaning what? When the distance was 500 kilometers, right? So the bird starts at this moment and ends when the two trains just meet each other. So after this much time. So the bird has moved for this much time with a continuous speed of 300 kilometers per hour. So the distance covered should be this into 300 kilometers per hour, giving us the answer. As simple as that. So just roughly calculating this. So we have 30 cancelling out between these two. We have 10 by 9. So we have 5,000 by 9 or roughly 555.55 kilometers. Not a good number to deal with, but as the data is. So simple enough?
Yes, sir, pretty simple.
Okay, so in this question, with the same premise, the question again, consider the lateral distance to be negligible. What is the sum of the distances that the eagle traveled towards the second train? Now, this is an interesting question. So we are looking for the sum of the distances that the eagle travels towards the second train, meaning from the first train to the second train, right? So every time the bird is moving towards the second train and then returning back, right? Something like this is happening multiple times, right? So we are supposed to select this plus this and so on as many times it happens. I hope that was understandable.
Right.
Now, if we take that into perspective, now this becomes complicated in this way. So let us simplify the problem first. So what I'm going to do is, I'm assuming that this is the distance that the bird covers to the second train, from the first train to the second train in its first motion. So what I mean by that is, in its first motion, it will not actually cover 500 kilometers, right? It will cover something less because by the time it reaches the second train has traveled something, right? We don't have to calculate that, but I'm saying this is the first distance that the bird covers to the second train. Now, what happens after this? So instead of doing a line, let me use arrows here. So let's say this is the distance to the second train. And let me use a different color for this. This is the distance to the first train, the first motion back to the first train. Now notice something interesting that happened. In this much time, the first train should have covered this distance. Because initially, when the bird started to travel, both the bird as well as the first train was here, right?
Correct.
And then it moves to the second train, comes back to where? To the first train again. So by this time, the first train should have covered this distance. Now let's repeat it once more and see. Let's see what happens. So again, the bird moves from the first train to the second train, obviously not till here, somewhere in the middle. Then it comes back to the first train. And by this time, again, the first train should have covered this distance.
Right.
So if you think it in this way, so let me say F indicates every motion of the bird. So let me use a blue color for this. F indicates every motion of the bird in the forward direction. So I'm calling the forward direction as first train to second train. And B indicates the motion of the bird in the backward direction. So from the second to the first train.
Right.
Every time this happens, the second train or the first train or the T1 or something has covered this distance, right? So can you notice that for every such scenario, we will have F is equal to T1 plus B.
Right.
Isn't it? Or rather, F minus B should be equal to T1.
Right.
Now, why I'm pointing on this way is, if you think about it, F plus B is equal to the total distance that the bird travels, right? I mean, this F and B is what the bird is traveling. Forward and backward, these are all bird cut travel, right? So F plus B should be the total distance that the bird travels.
Right.
And F minus B should be the total distance that the train 1 travels.
Correct.
So I'm going to develop a basic concept out here. If you guys want, you can just remember this if you want, or you can solve it after this point. So I'm just going to work on this a little bit so that you can understand what I'm doing. Now, this T1 is basically what? The total distance traveled by the first train, right? Now, the total distance traveled by the first train is speed of the first train multiplied to the time for which the train has been traveling, isn't it?
Right.
And the distance covered by the bird is speed of the bird multiplied to the time for which they are traveling.
Right.
And time for which they are traveling is constant. The time for which the first train travels, the time for which the second train travels, the time for which the bird travels, everything is constant, right? Because everything happens till the two trains just meet each other. Remember? So
correct.
T is a constant value, whatever be that constant. So if you just develop a simple logic out here, I'm just going to use the component to dividend to idea. So what I'm going to do is I'm going to divide F plus B by F minus B. So we have F plus B upon F minus B is equal to speed of the bird upon speed of the first train. So the T and T cancels out, right? So we have something like this. If I apply component to dividend on both the sides, this will resolve back to the original form because this is already the component to dividend form. So we'll have F by B is equal to SB plus S1 upon SB minus S1. So speed of the bird plus speed of first train upon speed of the bird minus the speed of first train. So why I'm doing this, because you can directly get the ratio of the first, the forward motion and the backward motion, right? So for instance, in this case, we have the bird speed as 300 and the first train speed. So always the first train speed matter. Which is the first train where you start from. Yeah, that is where that is how we have indicated this idea, right? So this is 500, this is 120. So just let me quickly calculate this ratio. So we have 620 upon 500 minus 180, so 120 rather. So that is 620 by 380 or something like this, right? So I'm not going to further reduce this because it will just help me in calculation. So we have a ratio of 62:38, something like this, right?
Right.
So this is the forward and backward ratio of the bird car travel. And remember from the last question, if you remember, the total distance of the bird car travel was 5,000 by 9 kilometers, which we reduced to 555.55 or something, right? So that was the total distance covered by the bird, right? That this D is. So this 5,000 by 9 should be divided in this particular ratio in forward and backward motion. And the question is about forward motion. So that should be 62 by 100 of the total distance.
Right.
Right. So just evaluate this and you get the answer. So the 100 goes off. 50 into 62 is as good as 100 into 31. So that is 3100 upon 9. Just reduce this and you get the answer.
Thank you, sir. It was really pretty interesting set, both the questions. So thanks a lot for having this question sets. Thank you everyone for joining in.
Thank you, sir. If you haven't yet checked the full playlist containing this video, then check the description for the direct link. Also, if you enjoyed this video and want to stay updated with our daily questions, tutorials, and problem-solving sessions, make sure to hit that subscribe button and the bell icon to never miss an update. In addition to our daily questions, we also offer comprehensive preparation for CAT and other management entrance tests. If you're looking to excel in these exams, we highly recommend checking out these courses in our website. To get a taste of what our courses have to offer, we invite you to take a free demo. The demo will give you a glimpse into the quality and effectiveness of our teaching methods, study materials, and practice resources. You can find the relevant links in the description of this video. Have a nice and successful preparation ahead. See you in the next one.